Hello guys, welcome to my YouTube channel. So today we are going to discuss how to analyze batch reactor data. So in our previous lectures we have discussed various methods of batch reactor data. One of the most important one is the integral method. We will discuss another method which is the differential method. Okay, so I will take up a small problem in order to make you understand. Suppose you have a set of suppose you have a set of data points. Okay, so I'll take some data points here. So time t in seconds and concentration of a particular reactant Ca in moles per liter. Alright, so these two data are given to you. So at time t equal to 0 you have concentration which is 10. At time t equal to 20 you have the concentration which is 8. At time t equal to 40 you have the concentration which is 6. At time t equal to 60 you have concentration which is 5. Suppose you have like this. So let's take another point. Suppose at t equal to 120 seconds you have concentration which is 3. Okay, so you have these data points. As you can see, as the time is increasing, the concentration is decreasing. So if you plot this data, with Ca in moles per liter on the y-axis and time in seconds, okay, on the x-axis, and suppose this is your here we are plotting the points. So 10, which is the concentration, will be here. This is 8, this is 6. Okay, so this is maybe 4 somewhere, and here we are plotting say like 100, 200, like this. Alright, so if you plot this data, so you will have first point will be here. Okay, first point will be here. This will be your first point. Then second point will be somewhere over here. Okay, so third point will be somewhere over here, like this. So if we continue to plot this, so what we get, this is sort of a curve. So this is the curve that we get. Okay, so this is the curve, and these are your data point. So what we will do next, we will draw tangents to each of these data points. Suppose we draw tangent to the first data point. So suppose we draw tangent to the first data point, so it will intersect the x-axis somewhere over here. So it is meeting say at 75 seconds. We can draw another tangent to this point which will meet somewhere on the x-axis. So we have to draw tangents to each of the data points, and then we will calculate the slope. Slope is calculated as minus of dca dt. So its slope is calculated as minus of dca dt. So it will be 10 minus 0. So initial concentration is 10, final concentration is 0, divided by 0 minus 75. Okay, so because 0 means initially when the concentration was 10 moles per liter, the time was 0. And when the concentration came down to 0, the time is 75 seconds. So here the value comes to 0.133. So likewise we will calculate all the slope. Then what we will have to do after calculating the slope, we will calculate log value of this slope. Okay, so log of minus of dca dt. So if we calculate the first value, for example, the log will be somewhere over minus 0.875. We will calculate the second value will be minus 0.987. Okay, so if we calculate the third value, it will be somewhere around 1.182. If we calculate the fourth value, it will be somewhere around minus 1.3. 387. At the same time, we will calculate the log value of CA. Okay, log value of CA also. So if we calculate the first value, it will be 1. Second value will be 0.903. Third value will be 0.778. Fourth value will be 0.699. All right. Now what we will have to do here, we will have to plot this. So we will again plot this. So this will be log of minus dCA by dt, and this will be log of CA. Alright, so what we get here also we get a curve like this. Next, what we will have to do, we will have to calculate the slope of this curve, and we will also have to calculate the intercept. Alright, now the question is why. So suppose we take an equation, rate equation for nth order kinetics. It is given as minus of RA is equal to minus of dCA by dt is equal to K into CA to the power of n. So if we take log both sides, it will be minus of dCA log of minus dCA by dt is equal to log K plus of n log CA. So this is very important. So it is of the form of y is equal to, so this term is y, this log K is actually your y-intercept, which is C, this n is actually your slope, and this CA log CA is actually the x, behaves as a x. So this slope will give you the value of n, and this y-intercept will give you the value of k. So if you know the value of n and value of k, you can say which order of kinetics it is, whether it is first order kinetics or second order kinetics or third order kinetics, whatever it is. So the usefulness of this solving of this method is that you know the order of kinetics. You can figure out the order of batch kinetics from this. So if you have the data of CA and time, concentration and time, so first you have to calculate the slope, and from that draw the tangent and calculate the slope, and from that you can find out the value of n as well as k. Right, so this is the end of the discussion of batch reactor. We will discuss some other types of reactions in a subsequent lecture videos. So if you like our videos, please do support us. As you know, this YouTube channel is not been monetized yet. So if you want to support us, you can scan this QR code on any UPI app, whether it's Google Pay, Phone Pay, Paytm, whatever UPI app you use. You can scan this Google Pay and send us whatever contributions you are. We assure you your small contributions will be significant in boosting this YouTube channel, and it will help us to improve our videos in future. So alternately, you can use this UPI ID. You can type this UPI ID, you can open your UPI app, and here you will get the UPI icon on the home screen of the UPI app. So this interface will show you the pay UPI ID or number. You can type this UPI ID and you can pay us whatever contributions you like. Your contributions will be beneficial in growing this YouTube channel and bringing the best of the YouTube videos to help clear your concepts in biotechnology.